Well, greetings, Mr. Colazar's class. Today we're going to start looking at section 11.2 in your notes. And our idea here for this is going to be what's known as the mole ratio. And so we're going to start our new subject here, and this is going to be really an important idea that we're going to be looking into to describe the correct balanced chemical equation in terms of particle ratio, mole ratio, and mass ratio with that law of conservation of mass. So our main idea for today is that mole ratio from the balanced chemical equation. Remember, our BCE is going to be that important part going forward, allows for different substances in a chemical reaction to be compared. So we can compare one thing to another thing, whether it's a reactant to another reactant or a reactant to a product, whatever it might be during that reaction. So for today, this idea of the mole ratio. A mole ratio is a ratio between the number of moles of any of the two substances in that balanced chemical equation. So remember, we need a balanced chemical equation is going to be that important part in order for this mole ratio to work out. With that mole ratio, what we're going to be using it for, the mole ratio is a conversion factor. So we're going to continue to be using those conversion factors or fraction that can be used to convert between substance and amount that's needed or produced during that reaction. So we're going to be going and setting it up. Remember, set up. So units cancel. So just as we've been doing so far during our work, what we're going to look at is how we can use these conversion factors using that balanced chemical equation. So for today, one of the reactions we're going to look at is aluminum plus oxygen produces aluminum oxide. In order for this reaction to work, remember Al2O3, aluminum was a +2 or +3, oxygen a -2. So when you crisscross, we actually got Al2O3, oxygen diatomic, so O2. To balance this reaction, 4 aluminums and 3 oxygens will combine to produce 2 aluminum oxides. So we're starting out with that balanced chemical equation. So using that balanced chemical equation, we're going to come up with our mole to mole ratios. So to look at that, our first one, how many aluminums to oxygen is our first mole to mole ratio? So if we look, 4 aluminums and 3 oxygens are going to be our first mole ratio. So our first ratio, 4 aluminums to 3 oxygens would be our conversion factor that we could use. Continuing, aluminum could also be compared to aluminum oxide. So aluminum to aluminum oxide, we would have 4 aluminums, 4 moles of aluminum would react to produce 2 moles of aluminum oxide. We could also look just the opposite way. Excuse me. Just like, 12 inches equals 1 foot, we could go between those two. So just the opposite way, we could go backwards, where oxygen to aluminum, it would be 3 moles of oxygen to 4 moles of aluminum, or 2 moles of aluminum oxide to 4 moles of aluminum. So we could look at those two either inverses of each other, depending on which way we're actually reacting. And then also we still have 2 more to look at. Oxygen to aluminum oxide, 3 moles of aluminum, or 3 moles of oxygen, 2 moles of aluminum oxide, or just the inverse, 2 moles of aluminum oxide to 3 moles of oxygen. So using this information, let's add this to the bottom of the page note-wise. Add to the bottom of page 2 in your notes. Let's add this problem to the bottom of page 2 in your notes. So let's write this one down. How many moles of O2 are needed to react to form 0.075 moles of Al2O3? So we're looking to find how many moles of O2 are needed to react to form 0.075 moles of Al2O3 from our balanced chemical equation above. So we know we're starting out with 0.750 moles of Al2O3, and we're looking to react to see how much oxygen are we going to need to react? So if we look up above Al2O3 to oxygen, that reaction is going to be set up. We need 2 moles Al2O3 to 3 moles of oxygen. Now the question is, which one of our conversions are we going to want to use or set up here? In this case, this top one is the one we'll look at, where we need 3 moles of oxygen, O2, to react with 2 moles of Al2O3. Setting it up this way so our moles can cancel our moles, leaving us with our oxygen. Now to do this math, 0.75 times 3 divided by 2 would give us about 1.13 moles of O2. So as we're working, if you start out with 0.75 moles of O2, mole-to-mole conversion between them gets us to our part there. This will allow us to work through that worksheet 1. Safe travels to everyone.